Everyone. Hello.
Good afternoon, sir.
Good afternoon. So we will start now. Previous class we have discussed about the phasor diagram as well as the circuit diagram of transformers operating at no load condition. Then we have also discussed the operation of a transformer when the load is connected across the secondary side, and accordingly we have drawn the phasor diagram, right? So today we will see the constructional features of single phase transformers. So what are the different components or what are the different parts, main parts involved in the construction of the transformer, and what is the constructional features of each and every component, that we will discuss in detail. So this is the block diagram, or you can say the representation of a single phase transformer. That is the photographic view of a single phase transformer. Uh, so you should know that there are various parts, but the most important part of a transformer are the windings, that is the high voltage winding and the low voltage windings, and the transformer core. So apart from these two components, there are other uh, parts also, such as transformer tank, then conservator, breather, bushings, high voltage, both high voltage and low voltage bushings, then explosion vent, then there are also insulation of the windings, insulation of windings, etc. So these are also used along with the core and the both type of windings in a transformer. So you can see the placement of these different components inside a single phase transformer. Here you can see the rectangular core on which there are two limbs, these vertical two limbs, on which the high voltage and low voltage winding has been done or wound, and the two output leads of each winding, that is high voltage and low voltage winding, are connected to the external bushings with the help of uh, wires at the two terminals of the winding. So here these are the terminal bushings. So from here the supply is coming inside. Suppose if we are operating this transformer in the step down mode, that is we are taking the supply at the two output terminal of the high voltage winding, then the supply will be coming inside the transformer through these two terminal bushings. These are basically insulators, right? So the purpose of these insulators or bushings is to isolate the live conductor and the transformer tank, बिकॉज ट्रांसफार्मर का जो टैंक होता है, बाहरी पोर्शन जो होता है, उसमें नहीं तुम्हारा इलेक्ट्रिसिटी फ्लो होना चाहिए, राइट? दैट में क्रिएट अनदर हर्डल. सो टू अवॉइड दैट द बुशिंग्स आर यूज्ड. तो यहाँ से सप्लाई आता है, एंड देन आफ्टर स्टेपिंग डाउन द वोल्टेज, अगेन द टू आउटपुट टर्मिनल्स आर टेकन आउट विद द हेल्प ऑफ these two output bushings, two output bushings. अब यहाँ से फर्दर आगे सप्लाई आगे बढ़ेगा, maybe to the loads or further to the distribution lines, right, depending on the voltage rating of the transformer. And then this outer body of the transformer is basically your transformer tank. These are basically your radiating tubes, radiating tubes through which In some cases, the oils are also allowed to flow through these tubes, and the purpose of these radiating tube is to radiate the heat outside the transformer tank. तो ये कूलिंग के लिए बेसिकली दिया जाता है, सो दैट द हीट जनरेटेड इनसाइड द ट्रांसफार्मर वो जो है दैट इज transferred to the external atmosphere. And then you have here you can see a element or component of Buchholz relay. So the purpose of this Buchholz relay is to provide the protection to the transformer through different type of internal faults taking place inside the transformer. तो ये जो है सो समझो कि Buchholz relay का purpose है for the protection point of view, right? So it protects the transformer from both severe and incipient type of faults, right? Then you have a conservator tank, and the purpose of this conservator tank is to store the additional oil or expended oil in the transformer. We will see later on that when the current flows through the winding, then it basically generates the heat, so the oil will get heated up, and if excess heat is generated due to overloading of the transformer or due to any fault inside the transformer, then the oil expands. तो ऑयल मान लो कि पहले यहां तक था, अब ओवरहीट होके जो है एक्सपेंड किया, then it will follow this path through this narrow tube, and it will be stored in the conservator tank, right? So again, when the transformer will be cooled down, the temperature of the transformer, when it will go down, then this oil will come back to the transformer main tank, right? So this is हेलो
हेलो सर।
Yes, sir.
आवाज आ रही? ठीक है। अब ये कंजर्वेटर से जो है सो एक कनेक्शन रहता है थ्रू नैरो ट्यूब्स टुवर्ड्स द ब्रेदर। तो ये जो कंटिन्यूअस प्रोसेस होता है, ऑयल कंटिन्यूअसली एक्सपेंड्स अप एंड कंप्रेस डाउन। तो इन दिस प्रोसेस सम यहाँ पे एक ब्रेदर का अरेंजमेंट होता है। द फंक्शन ऑफ दिस ब्रेदर इज टू अवॉइड द मॉइस्चर इनटेक इनसाइड द ट्रांसफार्मर। तो यहाँ से जो है सो जब भी तुम्हारा ऑयल आएगा तो यहाँ से कुछ एयर बाहर निकलेगा। when this oil will go down, then it will suck the air from outside environment. So silica gels are provided. Silica gel is provided in this breather to absorb the moisture from the air it is taking from the environment, right? So this is the function of the breather. Now we will discuss in detail about each and every component in the subsequent sections. So these are the different parts of a single phase transformer. Now depending upon the construction of the core, the transformer is of two types. First one is your core type transformer, and second one is your cell type transformer. So we will discuss about this core type and cell type transformer. You can see here the notation or representation of the core type transformer. So in core type transformer, the windings surround a considerable part of the core, transformer core. तो जैसे यहाँ पे देख सकते हो कि ये जो है ये रेक्टेंगुलर शेप, दिस इज बेसिकली ट्रांसफार्मर कोर, राइट? ये रेक्टेंगुलर कोर है। नाउ कोर का जो है ये वर्टिकल पार्ट जो होता है, वर्टिकल लेग्स, दीज आर बेसिकली नोन एज limbs, transformer limbs. So in core type transformer, two limbs are there, and this horizontal part both up and down, these are known as your yoke, right? So here you can see that these are the windings. ये winding को represent कर रहा है, इसको और हम लोग दूसरे representation से भी देखेंगे. तो ये windings surrounds the considerable part of the transformer core, right? But in case of cell type transformer, we will see that the steel core surrounds the major part of the winding, right? But first of all, talk about this core type transformer. This is the second representation of the core type transformer. Till now we have used this symbol only, where we have used the two separate windings on the two vertical limbs of the transformer, right? हाँ, so अब देखो इसमें होता क्या है कि in the core type transformer एक कंसेप्ट हम लोगों ने पढ़ा था मैग्नेटिक सर्किट में, लीकेज फ्लक्स का. I hope you can remember this term, leakage flux. So there is some flux which leaks through the core legs and non-magnetic material surrounding the core, right? तो जैसे कि ये अगर तुम लोगों को याद हो डायग्राम, यहाँ एक वाइंडिंग था. This is your low voltage winding, suppose. So when current was flowing through this, then flux was developed, right? So which flux was the main flux or useful flux? The flux which links both the primary and secondary winding is the useful flux in the transformer. But you can see that some part of the generated flux links only this high voltage winding, and some part of the flux links only the low voltage winding, right? So these fluxes are known as your leakage flux, right? In iron core of the transformer, most of the flux is confined to the high permeability transformer core, but there are some flux, some amount of flux that links through the core legs and the non-magnetic material surrounding the core. So this flux is known as your leakage flux, which does not links both the windings of the transformer, right? So it is always desirable to reduce the amount of this leakage flux, right? इस leakage flux को हमेशा जो है so decrease जितना होगा उतना transformer का performance will be better, because you know that when we talk about the performance of the transformer, then everything depends upon the rate of change of flux, right? So if the main flux strength reduces due to the presence of leakage flux in the transformer, then obviously the output voltage will decrease. So it is always desired to improve the transformer performance by reducing the amount of leakage flux, right? So now there are different ways to reduce the amount of leakage flux, right? So in case of core type transformer, this can be achieved by placing half of the winding, half of the suppose low voltage winding over one leg and other half of the winding on the second limb of the transformer or leg of the transformer. Means मैं कहना क्या चाह रहा हूं कि सपोज जैसे कि फिर से ये डायग्राम ड्रॉ करें हम लोग, right? This is your leg 1 or limb 1, this is limb 2. So we can think about the winding in this way. Suppose ये है high voltage winding, right? तो हाफ जो है एक लेग पे कर दिए और सेकेंड हाफ जो है इसका पार्ट वो इस तरह से कर दिए और इसको फिर इधर ले आए. So across this terminal your supply will be given, suppose V1. Now similarly, suppose this is your low voltage winding. So half is done here and other half is done in this way, और इसको फिर से यहाँ इस टर्मिनल पे ले आए. So these are your two output terminals. So in this way, suppose यहाँ से जो current flow करेगा, this current is flowing through this winding in this way, right? ये फिर चला गया इधर, and the same current will be flowing through the winding placed on the two different limbs, right? तो जितना फ्लक्स यहाँ जनरेट होगा उतना ही फ्लक्स यहाँ भी जनरेट होगा. So in this way, to some extent we can reduce the amount of leakage flux in a core type transformer, right? समझ में आया ये? समझ में आया कि नहीं आया? चलो इसका दूसरा रिप्रेजेंटेशन भी देखो, किसी किसी बुक में रहता है कैसे. Suppose this is the core of the transformer, right? तो कहीं कहीं देखोगे इस तरह से रहता है दिया हुआ. This is your low voltage winding. इसके ऊपर रहता है high voltage winding. There is some insulation between the low voltage winding and the high voltage winding, and also the core is isolated from the winding, right? क्योंकि windings जो होता है, winding material जो रहता है कॉपर का, अगर winding है, winding is basically done by coils. तो coil जो होता है उसके ऊपर कुछ laminations जो है वो provide किए जाते हैं in order to avoid the short circuit between the adjacent turns of the winding. So these are, suppose, high voltage winding. So this is your high voltage, these two, and these two are your low voltage windings. And similarly on the another leg also, the winding, half of the winding is done on the one limb and half of the winding is done on the another limb of the transformer. Again, this inner one is represents your low voltage winding and the outer one represents the high voltage winding, right? समझ में आया ये कोर टाइप ट्रांसफार्मर कैसे बनाया जाता है? बोलो भाई, समझ में आया कि नहीं समझ में आया?
इसमें सर एक बार ये बता दीजिए कि फ्लक्स लीकेज क्यों नहीं हो रहा है इसमें. ये तो ठीक है, आ गया समझ के बनाया कैसे जाता है, लेकिन लीकेज कैसे कम हुआ?
देखो, अभी हम लोगों ने क्या बात किया था कि जो फ्लक्स सिर्फ एक वाइंडिंग को लिंक हो रहा है जिसके साथ, उसको हम लोग लीकेज फ्लक्स बोल रहे हैं. द फ्लक्स व्हिच इज लिंक्ड विथ either of the winding is known as leakage flux. और यूजफुल फ्लक्स कौन है? जो दोनों वाइंडिंग को मतलब जिसकी वजह से दोनों वाइंडिंग में रेट ऑफ चेंज ऑफ फ्लक्स हो रहा है, दैट इज योर यूजफुल फ्लक्स. ठीक है. सो हियर वी हैव सीन दैट this part of the flux and the outer one for this secondary terminal winding, these two are basically your leakage flux, right? In this case what will happen, मान लो कि यहाँ पे कुछ करंट फ्लो हो रहा है, ठीक है, तो फ्लक्स जनरेट होगा, जो करंट का मैग्नीट्यूड होगा टोटल इस वाइंडिंग के थ्रू, उसके अकॉर्डिंग फ्लक्स विल बी जनरेटेड, राइट? सो इन दिस केस यू कैन सी दैट the amount of flux generated here in this winding, ठीक है, और यहाँ पे जितना हो रहा है, तो दोनों लिंब पे ये लिंक कर रहा है. तो अगर यहाँ से कुछ फ्लक्स जनरेट हो रहा है, तो सेम अमाउंट ऑफ फ्लक्स विल बी जनरेटेड हियर आल्सो, एंड द सेम फ्लक्स विल बी लिंक्ड इन द सेकेंडरी वाइंडिंग आल्सो, और यहाँ पे भी वही होगा. सो द नेट लीकेज फ्लक्स will reduce compared to this condition. मैं ये नहीं कह रहा हूं कि लीकेज फ्लक्स होगा ही नहीं इस केस में. देयर विल बी लीकेज फ्लक्स इन दिस केस आल्सो, राइट? बट the magnitude of the leakage flux will be reduced compared to this condition. ठीक है, there will be leakage flux. Right? बोल ही नहीं रहे हो कुछ, चलो आगे बढ़ो. Now next one is your cell type transformer. So in the previous case, in case of core type transformer, what we have seen that the winding material was surrounding the core of the transformer, right? But here in case of cell type transformer, the core material surrounds the winding. ठीक है, तो ये तुम समझ सकते हो, दिस इज बेसिकली ए 3 लिम्ब ट्रांसफार्मर. मान लो दिस इज L1, दिस इज L2 and this is L3. Similarly here also L1, L2 and L3 are the 3 limbs of the transformer, right? So in the cell type transformer, the low voltage winding and the high voltage winding are wound over the central limb. This is your central limb. L2 is the central limb. So both the, suppose this is your primary winding, which is suppose let us consider this is high voltage winding and this is low voltage winding. So both the low voltage winding and the high voltage windings are wound over the central limb, right? And are interleaved, or you can say sandwiched. The sandwich type of winding is used in this condition. Concentric winding is not used in case of cell type transformer. सैंडविच का मतलब क्या होता है, एक के ऊपर दूसरा, दूसरे के ऊपर तीसरा, इस तरह से, राइट, वन ओवर द अनदर. तो इसको इस तरह से भी बेटर वे में अंडरस्टैंड हम लोग समझ सकते हैं. लेट अस ड्रॉ इट, द सिंपल ब्लॉक डायग्राम in this form. Let us draw the two window. The central limb is basically, the thickness of the central limb is more compared to the two outer limbs, because you know that when winding will be wound on the central limb, so the flux will be generated and these fluxes will be distributed in these two paths. And now you know that phi is equal to BA, right? तो अगर फ्लक्स इसमें phi है, मान लो phi flux is generating, so this will be phi by 2 and this will be phi by 2. So you can see that the flux is more in the central limb, therefore the area of cross section of the central limb will be more. बताइए. ठीक, आज आशीष नहीं आए क्या? अच्छा ठीक, ठीक है ठीक. So due to the concentration of more flux in the central limb, the area of cross section is just double compared to the two outer limbs of the transformer, if the two outer limbs are identical in nature, right? Now what happens, we were talking about the low voltage winding and high voltage winding, which is sandwiched in nature. So in this way the winding is done. Right, these two outer one is your low voltage winding, ये भी लो वोल्टेज है, ये लार्जर जिसका दिख रहा है तुमको क्रॉस सेक्शन, दिस इज योर हाई वोल्टेज वाइंडिंग इन बोथ द केसेस. So low voltage and high voltage winding are wound over the central limb, and the sandwiched type of configuration or winding is used, right? Here you should note that the bottom and top, the bottom means ये bottom वाला हो गया winding, ये top winding हो गया, right? So this is bottom, this is top. So the bottom and the top low voltage coils are of half the size of the other low voltage coils. ये जो होगा इसका जो क्रॉस सेक्शन होगा, जो अदर लो वोल्टेज है, यहाँ बनाने में थोड़ा दिक्कत हुआ है। हेलो, हेलो।
यस सर।
इसको सिर्फ इस तरह से बना के देखो, सेंट्रल लिम्ब को बनाओ तब ठीक से डायग्राम बन पाएगा। सपोज दिस इज द सेंट्रल लिम्ब, राइट? In this way we will draw, and both sides we will have other limbs. So let us draw again this winding. So this is your low voltage, then high voltage, then low voltage, then again high voltage, and this is your low voltage. So you can see that the bottom low voltage and the top or low voltage windings are having half cross section compared to the other low voltage windings, right? इसका रीजन बताओ क्या हो सकता है? Anyone can respond? Because here whenever the winding materials or windings are used, so you will have to provide the insulation between the winding and the core material, right? So if suppose we will use, first of all, suppose high voltage instead of the low voltage winding, then what will happen? Higher amount of insulation will be required between the high voltage winding and the transformer core. तो इससे कॉस्ट बढ़ेगा ट्रांसफार्मर का, राइट? तो लो वोल्टेज ही होना चाहिए, दोनों अपर टॉप मोस्ट एंड द बॉटम मोस्ट वाइंडिंग शुड बी लो वोल्टेज वाइंडिंग। अब ये बताओ ये क्यों होता है, हाफ क्यों रखा जाता है? चलो इसको तुम लोग सोचना और आंसर इसका खोजना क्या होगा, ये पूछेंगे फिर आगे जब ट्रांसफार्मर, तो अभी चल ही रहे पढ़ाई, राइट? So this is the constructional features of the core type and cell type transformer. If you have any confusion, you can ask. This is the difference, comparative study between the two type of transformers. We have already discussed about this. Now, this part we have already discussed. What is this? Okay, so now we will talk about the magnetic core of the transformer. Magnetic circuit or magnetic core of the transformer, right? So so we have seen that the magnetic circuit of the transformer can be of either core type or cell type, right? As we have discussed in the previous slides. So in case of core type transformer, we have seen that there was only one iron path, which is usually in the rectangular form, and the windings are wound on the two opposite limbs of the transformer, right? ठीक है, just a minute, wait करो। हेलो, हम्म, ठीक है, अभी क्लास में बाद में। हाँ, तो हम लोगों ने देखा कोर टाइप और सेल टाइप ट्रांसफार्मर के बारे में. So in both the types of the transformer core, the magnetic circuit is made up of laminated iron core, right, where thin silicon sheet steels, thin silicon steel sheets are used to design the transformer core. All these thin sheets are stacked together. Thin silicon sheets are stacked to form the desired cross section of the transformer. So the main purpose of using the thin silicon sheets, which is also known as your laminations, ये हम लोगों ने पढ़ा है मैग्नेटिक सर्किट में, लैमिनेटेड शीट यूज करते हैं. सो द कोर इज लैमिनेटेड मेनली टू reduce the eddy current loss, right? So you know why eddy currents are developed in the transformer core. So eddy currents are induced in the core because the core is cut by alternating flux produced in the core due to the flow of alternating current through the windings. So this eddy current basically circulates in the transformer core and it gives rise to the I square R heating loss in the transformer core, right? So in order to reduce this eddy current loss, the core is built up of laminations. How it is done we have already discussed कि जब हम लोग thin sheet यूज कर लेते हैं, then the magnitude of the circulating current reduces due to the lesser cross section of each and every laminated sheets, and all the laminated sheets are insulated from each other by a thin layer of varnish insulation between the laminations. Therefore the effective area of cross section decreases. So if area of cross section decreases, this will in turn increase your resistance, and if resistance will increase, then you know that IE, that is eddy current, will reduce. This will further reduce the IE square R value, which actually produce the heat in the transformer core, right? So in this way, using laminated sheets in the transformer core, we can reduce the eddy current loss in the transformer. So I have also told that the thickness of these laminated sheets are of the order of around 0.4 millimeter or even less, right? But thickness normally cannot be reduced below this value, 0.4 mm value, because it will influence the or affect the mechanical strength of the laminations, right, which will greatly reduce, right? So along with this eddy current loss, we have some hysteresis loss taking place inside the transformer core, right? Now what is this hysteresis loss? So hysteresis loss occurs in the core as it is subjected to alternate magnetization and demagnetization of the transformer core. जो हम लोगों ने बात किया था कि when all the grains gets oriented in the same direction, so in another half cycle the direction of the orientation of the grains will change. So in this process some power is lost, which is known as your hysteresis loss. Now the amount of that power can be calculated from the area of cross section of the hysteresis loop, right? Therefore special silicon sheets, special silicon steel sheets where we have the silicon content of around 4 to 5% is used for the laminated sheets, for the design of the laminated sheets, right? So this type of special silicon steel sheets has normally a smaller hysteresis loop area, but high value of saturation flux density as well as resistivity. तो इसका क्या होता है, such type of special silicon sheets, you have a small hysteresis loop area, right, but having high value of saturation flux density and also high value resistivity. So by adding silicon content in the steel sheet, we basically increase the resistivity of the magnetic material, right? So when resistivity will increase, then you know that the power associated with that material will reduce, right? Thus, the hysteresis loss and eddy current loss both will be minimized by using the thin laminated sheets of the iron core or transformer core, when we will use the thin laminated sheet of the iron core, right? So nowadays, mainly CRGO sheets, steel sheets are used. The full form is cold rolled grain oriented silicon steel. इसका फॉर्मूला यही बस होता है, cold rolled grain oriented. So this type of silicon steel sheets are mainly used to design the transformer core, for the construction of the transformer core. So the main advantage is that this type of material basically reduces the magnetizing current. It reduces the magnetizing current, which is taken by the primary winding. Now, what is magnetizing current? ये तुम उससे समझ सकते हो, जो नो लोड करंट हम लोग जो कंसीडर किए थे, उसका जो है दो पार्ट था. एक था लॉस कंपोनेंट, राइट, IC, and second one was the IM. So IM is basically your magnetizing component of the no load current, right? तो एडवांटेज क्या हुआ, इट रिड्यूसेस द मैग्नेटाइजिंग करंट. करंट इनटेक जो है इसको कम चाहिए फॉर द बेटर मैग्नेटिक प्रॉपर्टी ऑफ द स्टील शीट, राइट? ये समझ में आ रहा है कि नहीं आ रहा है? थोड़ा थियोरेटिकल है ये, लेकिन ये जरूरी है समझना, कंस्ट्रक्शन से रिलेटेड है. अब कैसे जो है सो CRGO को यूज करने से बेनिफिट होता है, वो यहाँ से हम लोग समझ सकते हैं फर्दर. जस्ट आई विल रिव्यू दिस. इसको रिव्यू हम लोग कर सकते हैं कि अब देखो मैग्नेटाइजेशन प्रॉपर्टी पे जाना पड़ेगा फिर, कि इफ वी सपोज ड्रॉ द फ्लक्स वर्सेस मैग्नेटाइजिंग करंट, this will be same, this will have the same characteristics, जो कि BH characteristics जो हम लोगों ने ड्रॉ किया था, field density versus the magnetic field intensity vector BH, right? तो इस लोकेशन में क्या होता है, सपोज देयर इज ए मैग्नेटिक मटेरियल, so the dipoles or grains are randomly placed. They just started to orient themselves in a particular direction. So you can see that all the grains are randomly placed inside the magnetic material. Now as you will increase the magnetizing current, so gradually the performance of the magnetic material will improve. So at this point of instant, suppose the dipoles or grains are aligned to some extent in a particular direction. not completely, but the property of the magnetic material at instant 2 is better than at instant 1. Now in this region, suppose if we talk about this point when the magnetic material gets saturated, what does it mean? It means that all the grains are, or dipoles are oriented in a particular direction. So this is the best magnetic property of this particular magnetic material, right? So the conclusion from here is that when a magnetizing force is applied, the grains orient themselves in the direction of magnetization, right? ये मैग्नेटाइजेशन के डायरेक्शन में ओरिएंट हो जाएंगे सारे के सारे ग्रेन्स और डोमेन्स और डाइपोल्स, right? So the higher the magnetizing force, the more will be the orientation of the grains. So when almost all the grains becomes oriented in a particular direction, you can say that the core is said to have become saturated. So this is the saturation zone or saturated condition of the magnetic material. Now what is happening with this CRGOS sheet? So by cold rolling, the laminated sheets by cold rolling of the laminated sheets, the grains are actually made to orient to some extent in the direction of rolling, right? So by this mechanical property of the which is applied on the CRGOS sheet, the grains are made to orient to some extent in the direction of rolling. So even if the property of the CRGOS sheet is that even if you are not exciting this magnetic material made up of CRGO, cold roll grain oriented, without any external excitation, the grains will be oriented to some extent in the direction of rolling of the magnetic material. तो जो प्रॉपर्टी सपोज यहाँ सेकंड कंडीशन में आ रहा है. So how this property was achieved? When we have excited the magnetic material through external source, that is when you are applying the exciting current through the coil wound on the magnet, electromagnet. But here in case of CRGO sheets, without any external excitation, due to the cold rolling of the laminated sheets, the grains are automatically oriented to some extent in the direction of magnetization. So lesser current, magnetizing current, lesser current will be required in order to completely orient the grains in the same direction, right? That is, the magnetizing current required to fully orient the grains in any particular direction will be comparatively smaller than the case of non-oriented steel sheets. ठीक है, ये समझ में आया कुछ जो ये इतना कहानी जो बोला गया है?
यस सर, ठीक है.
हाँ, तो यही एक बेनिफिट है कि लेसर अमाउंट ऑफ एक्साइटेशन करंट इज रिक्वायर्ड. तो होगा क्या? तो इससे बेनिफिट ये मिलेगा कि सपोज एक कोई ये सीट है, पीस ऑफ ग्रेन ओरिएंटेड स्टील सीट, grain oriented steel sheet, where you can see that these are the direction of the domains or grains, that is they are aligned, all aligned in the same direction, right? तो अब सपोज हमको जो है इससे एक लेमिनेशन और लेमिनेटेड सीट तैयार करना है इन ऑर्डर टू डिजाइन द ट्रांसफार्मर कोर, ठीक है? तो पॉसिबिलिटी क्या है कि हम इस क्रॉस सेक्शन का, रेक्टेंगुलर क्रॉस सेक्शन का इस सीट से एक पीस कट कर लें, जैसा कि कोर टाइप ट्रांसफार्मर होता है. तो सपोज दिस इज द piece which we have cut through this seat of CRGOS, राइट? यही है। तो इसमें देखो आप, ये वर्टिकल लिम्ब में क्या है? डायरेक्शन ऑफ ग्रेन्स इन दिस डायरेक्शन। फिर यहां भी इसी डायरेक्शन में, हर एक में ऐसा ही है डायरेक्शन। यहां से कट किए हैं, ठीक है? देखो हर में तो वही है ना, हॉरिजॉन्टल, हर पोर्शन में कट पीस के। तो अब देखो, अब जब यहाँ पे वाइंडिंग प्लेस करेंगे, यहाँ पे सपोज प्राइमरी, यहाँ पे सेकेंडरी, तो फ्लक्स प्रोड्यूस होगा। तो फ्लक्स कैसे फ्लो करता है ये तो पता है सब लोगों को, ये ऐसे फ्लो करता है फ्लक्स ट्रांसफार्मर कोर में। सो नाउ यू कैन सी दैट in this horizontal portion of the core, which is known as yoke, in the both yoke section, the flux is in the same direction of the oriented grains. grains का ये orientation है, flux भी उसी के parallel में flow कर रहा है, right? That is, grains are already oriented in the direction of flux, but in the vertical limbs, suppose L1 and L2, the flow of flux is perpendicular to the direction of the grains. So what will happen? A large magnetizing force will be required to orient the grains in these two limbs. The orientation of the grains should be always in the direction of the flux. ठीक है? नहीं तो होगा क्या? You will need a large magnetizing current in order to align these grains in the direction of flux, यानी कि इस डायरेक्शन में, राइट? तो ये फिर पॉसिबिलिटी गलत हो गया, ये वाला जो है सो कंस्ट्रक्शन फेल कर गया तुम्हारा। नाउ सेकेंड ऑप्शन, अब मान लो सेम एक सीट है, CRGO सीट, ये है ओरिएंटेशन ऑफ द ग्रेन्स। अब मान लो कि हमको एक ट्रांसफार्मर कोर बनाना है, तो सपोज आई कट ए पीस फ्रॉम हेयर, मान लो कि ये ए है, ये है ए डैस्ट। फिर मान लो कि एक हम ऐसा कर लेते हैं, बी, बी डैस्ट। फिर एक ऐसा कट कर लेते हैं, सी, सी डैस्ट। और चौथा ऐसा कट कर लेते हैं, डी, डी डैस्ट। अब इसको ऐसे बनाओ, ए डैस्ट को सपोज वी पुट इन दिस वे, ठीक है? सपोज दिस इज ए, दिस इज ए डैस्ट। मान लो कि बी डैस्ट को कुछ ऐसे रख लेते हैं, बी डैस्ट। देन अगेन सी डैस्ट, सब में इसी डायरेक्शन में। एंड देन यू हैव डी, डी डैस्ट। Now, if all these cross sections, cut cross sections, are joined together with the help of either suppose bolted joint or जो भी करें joint के लिए mechanical procedure, so you can see that almost in all the limbs except the cross section, जो joining terminal है seats का, everywhere inside this magnetic material the direction of flux will be parallel to the direction of grains. So in this case, this is valid for except the corner regions, right? So in this case, the magnetizing current will be comparatively lesser than this condition. ठीक है? ये समझ में आया क्या कहना चाह रहे हैं?
Yes, sir.
ओके। अब एक तीसरा कंडीशन लो, यहाँ भी कुछ प्रॉब्लम था, कॉर्नर पे दिक्कत आ रहा था, जहाँ पे जो है सो 90 डिग्री लगभग जो है सो फ्लक्स हो जा रहा है उसके ग्रेन्स के। तो अब मान लो कि हम इस तरह का एक सपोज वी हैव ए सीट, सेम CRGO सीट। अब इसमें से अगर ऐसा कुछ कट करें, 45 डिग्री पे मान लो अगर कट कर लेते हैं, इस शेप में 45 डिग्री पे अगर कट करते हैं, ये है डायरेक्शन। And if now we connect these magnetic materials of this cross section, which is cut at 45 degree angle, then further the magnetic property will be enhanced due to the even at lesser value of the magnetizing current. So in this condition you will see that the flux, the useful flux of the transformer will be totally aligned with the direction of grains. Actually the grains will be totally oriented in the direction of magnetic flux. So least amount of magnetizing current will be required. It has been observed that least least Im is possible or is obtained when the magnetic material is cut at an angle of 43 डिग्री एंड 47 डिग्री। मान लो कि इस पीस को कट किए, यहाँ पे इसको कट किए हैं तुम्हारा 47 डिग्री पे, अगर ये एंगल है 47 डिग्री, तो ऑब्जेक्टिव रहता है कि ये दूसरा जो एडजॉइनिंग हो ये 43 डिग्री हो। ठीक है, तो इन दिस फॉर दिस एंगल ऑफ कट इट हैज बीन ऑब्जर्व्ड दैट least magnetizing current will be required. So this is all about the construction of transformer cores. किसी को कोई confusion हो, कोई question हो तो पूछ सकते हो, otherwise I will conclude the class today. Time हो चुका है, बताओ any question? No question. Thank you. बताओ आज तुम लोग क्या डाउन क्यों हो, तुम लोग कुछ आवाज किसी का नहीं आ रहा है, सो रहे हो सब?
नो सर।
अच्छा ठीक, थैंक यू।